This lesson begins a chapter that involves what we call quantitative chemistry. And so quantitative refers to something that deals with numbers. So we're going to look at the math of chemistry in this section. How we keep up with how much of different chemicals we have, how much have reacted, how much are left, the percentages, and so on and so forth. So we'll start with some introductory calculations in this section by calculating what is called the molecular weight and the mass percent. So these are the two things you should be able to calculate by the end of this lesson. Okay, the first thing is what is known as the formula or the molecular weight. Now these two are the same, they just have different vocabulary depending on what we're talking about. So formula weight usually refers to a network solid. So that could be covalent network or ionic compounds. So it could be a covalent network or an ionic compound. And molecular weight usually refers to molecules, which is going to be our normal molecular covalent compound. Remember from the last chapter, covalent network are things like diamond, sand, graphite, but most covalent compounds are molecules. And then ionic compounds are going to be in like a network as well. So we'll use the term formula weight. It's just vocabulary, okay? We use molecular when we're talking about covalent molecules, and we use formula weight when we're talking about ionic compounds. So don't let that confuse you. They're both asking you for the same thing. What are both of these things? They are, so both of these things refer to this. It is the sum, so that means we're going to add, of the atomic masses of the atoms in a formula. So the formula weight or the molecular weight is just the sum of the masses in that formula. Okay, for example, if we wanted to find the formula weight for magnesium hydroxide, well, first we have to remember how to write a formula. So remember, magnesium has a +2 charge, and hydroxide has a -1 charge. So we need 2 hydroxides and 1 magnesium. All right, so once we have our formula, then we're going to find the mass of each atom in the formula. So we have 1 magnesium, and it has a mass of 24.31 AMU. We have 2 oxygens, because it's in that parentheses, and each oxygen has a mass of 16.00 if we round to the second decimal place. So there's 2 oxygens, so I'm going to multiply that by 2. And then there's also 2 hydrogens. So I'm going to multiply 1.01 by 2 as well. So it's just that simple. You just take the mass for each one. You're going to multiply it if you have more than one. And then you just add them together. So the formula mass for magnesium hydroxide is 58.33 AMU. And that unit stands for atomic mass unit. So it's just the unit that we use when we're talking about the atomic mass or the formula weight. All right. Now, we need to be able to do that to determine what is called the mass percent. And that is the percent by mass, of course, of an element in a substance. For example, on magnesium hydroxide, I could figure out what percent of this compound is magnesium, or what percent is oxygen, or what percent is hydrogen, for example. So the formula is given here. The mass percent of some element, so this could be any element, and you'll just insert whatever element it's asking you about. So the mass percent of some element in a compound is equal to the number of atoms of that element in the compound, so this right here is going to be a whole number, times the element's atomic mass, and that's going to come from the periodic table. And then you're going to divide by the total formula weight of the whole compound. Okay, and then you'll, of course, multiply by 100 since we're looking at a percentage. Okay, so let's look at an example problem. Ilmenite is a natural source of titanium. Find the mass percent of each element in the mineral ilmenite, and then it gives us the formula. So this is an important concept because if I want to get titanium from some source, I want a source that has a high percentage of titanium. I don't want to mine some substance that's 1% titanium if my goal is titanium. I want to find a more efficient source. So the question is, what percentage of iron is in this compound, what percent of titanium, and what percent of oxygen? So we will walk through all three of those, and on your notes there's a separate slide for each one. So we're going to start with the mass percent of iron. Alright, so to find the mass percent of iron, we're going to do the percent for iron equals, okay, on the top we're going to do the number of iron atoms, so there's one iron atom in this compound, times the mass of iron. And we're going to stick to 2 decimal places on our masses. So from the periodic table, that's 55.85 AMU divided by the total mass of the compound. So I'll have to figure out what the total mass of the compound is. And I'm going to pull up my calculator for that. So for iron, titanium, and 3 oxygens, I'm going to do 55.85 plus titanium is 47.87 plus then oxygen times 3. So oxygen is 16.00 times 3 would be 48.00. So that's my total. So that would go on the bottom. So we've got 1 iron on the top and this 151.72 on the bottom. So it erased what I just did, unfortunately. So we had 1 times 55.85 AMU on the top, and then 151.72, and that's also AMU on the bottom, and then we'll multiply that by 100 to get the percentage for iron. Now notice your AMU cancel, so when you're finding the percent of something, the only unit left is your percent sign from multiplying by 100. So we'll do 1 times 55.85 divided by that total, and that will give us our percent. Now note that your total doesn't change. So when we go to calculate the percent titanium, this is still going to be our total, and the same thing on the oxygen. Right? So you see that worked out there, 1 times the iron and then the total on the bottom, and it comes out to be 36.81%. Right? That's the mass percent for the iron. Then we can do the same thing for the titanium and the oxygen. So for the titanium, there's 1 titanium in the compound times the mass of titanium. And what this dash means is that's the mass for every titanium atom, per titanium atom. All right, then there's that total on the bottom. We know it's going to be the same total every time because it's the same compound. And then we'll multiply by 100. Right, so you see that worked out. It turns out to be 31.56% titanium. Now we do the same thing for oxygen, but there are 3 oxygens in the compound. There's going to be a 3 there. That's not 30, that's 3 oxygen atoms times 16 per every oxygen divided by that same total again, and that turns out to be 31.64%. So they're each been about 30%. Now, one way to check your work on this is not the answer, okay, this stuff in red, this is just your check. You can add your percentages together and they should give you something really, really close to 100. All right, so to find the percent for the element, you do how many of those elements times its mass divided by the total, and that'll give you the percent for that element. Make sure you label them. So you say this is the percent oxygen, this is the percent titanium, this is the percent iron. Otherwise, you just got a bunch of random numbers on your paper. All right, let's do another example. And this is when we want to know the percent of water in a hydrate. Okay, this is important because water is in a lot of our compounds that we have stored in the lab. So when I weigh the compound, I want to know, okay, how much of this that I'm weighing is water and how much of this is my actual compound. So if they ask you for the percent of water in a hydrate, you're going to follow a very similar formula. You're going to do the number of water molecules on the top times the weight of water. Okay, and we know the weight of water would include 2 hydrogens and an oxygen. And then you'll divide by the formula weight of the whole compound, including the water. Add that down there, including the water. Or waters, if there's more than one in there. Okay, and then you divide and multiply by 100. So same scheme that we've been using. Right, so let's look at an example. Calculate the mass percent of water in aluminum chloride hexahydrate, right? 6 is hexa. So we need to find percent water. So we're going to do percent water equals. On the top, we're going to have 6 times the mass of water. So for water, we've got 2 hydrogens and an oxygen. Each hydrogen is 1.01. We have to multiply that by 2, and then we've got 16.00. So all together, 16.00, and then 2 of that, I think that'll be 18.02. AMU. That's on the top. And then the whole thing on the bottom. So for the whole thing, we need the aluminum, 3 chlorines, and the 6 waters. All of that added together will go on the bottom. So I'm going to let you see that typed out a little bit neater. So you've got your 6 times your water on the top, and then you've got the whole thing on the bottom. There's the aluminum, there's the 3 chlorines, and there's the 6 waters. Okay, then you do the math, and it turns out to be 44.7, I would say 78. I probably wouldn't have used that many decimal places. 78% water. Now, why is that important? If I'm going to buy some of this chemical from Flynn, that's who I buy most of my chemicals from, and they are charging me per gram, for example, like they say 200 grams cost this much. Well, almost half of that is water. I'm paying them for almost 100 grams of water if I'm buying 200 grams of the substance, right? Because almost half of it is water. So those sorts of calculations give us an idea, especially in industry when you're manufacturing chemicals or using chemicals to manufacture things, you really care about these percentages. All right, one more example is going to have us work backwards. So this is a little bit more algebra. A sample of calcium carbonate has some impurities in it. Whenever you see this word, impurities, that means that the mass that we would weigh on the scale would not be the mass of just this stuff, right? There's some gunk in there. There's some unknown. But it is found that calcium makes up 11% of the sample. And all the calcium in there comes from calcium carbonate. So find the mass percent of the calcium carbonate in the sample. So we have the percentage of the calcium. We want to know the percentage of the calcium carbonate. Right? So how do we do that? When you come across questions like this, we're going to set up a ratio to solve. All right? So whenever we have impurity problems, we want to be thinking about a ratio. So our ratio here is going to be the left side is coming from our formula. So we've got calcium on the top and the whole thing on the bottom. Equal to the percent of calcium, they gave us that, 11%, over the percentage of the whole thing. We don't know that. That's our x. All right? So whenever you do ratios, you need to have the same thing on the top on both sides and the same thing on the bottom. Not the same number, but the same concept. So on the top we have calcium. Calcium from the periodic table, calcium from our percentages. On the bottom, the whole thing from the periodic table, the whole thing from our percentages. And this is my unknown. And then I'm going to cross multiply. Well, first they did the math here. So they added up the top. That was just 1 times 40. So that turned out to be the same. And then added up the bottom. Okay, and now I think I can cross multiply. So we're going to multiply 40.08 times x and 0.11 times 100.09, and then we'll set those equal to each other and divide by 40.08. So we're going to cross multiply and then divide and make sure you come up with this 0.27, and that is 27%. All right, so make sure you can do that math. Once you finish this video, you're going to go look at the worksheets. The worksheets are asking you questions very, very similar to what we just did. All right, so answer questions 1 through 8, and we'll check those and make sure you're on the right track.